Hello, I'm Nathan, and I'll be walking you through the process of calibrating the WorkSeries printers. There's 4 steps to the process. First is to align the actuators, then we're going to level the bed, then we're going to set our extruder heights, and finally we'll run some test prints to validate the setup. The first step to calibration will be to align our axes. We have to align both our Y and our Z axes. To do this, we need a tool like a setup block or something similar with parallel surfaces. So first we're going to align our Z-axis. So we have to raise the Z-axis to about 30 millimeters. Distance might vary depending on the model of machine. So we'll go to our control menu, move, and then we'll move the Z-axis up by 30 millimeters. Now that our Z-axis is at 30 millimeters and we've moved our X-axis out of the way a little, we're going to measure the distance between the carriage and the V-rail on the bottom side of the axis. We'll use our setup block to do that. We'll just insert this in. Right now, there's a little bit of a gap between the top, so it's a very loose fit. So in order to level everything out, we'll actually remove power from the machine. You just press the off button. And then we're going to go down to our motor coupling. We'll remove the black cover and turn the motor coupling by hand to move the axis up or down until it's just touching the top of the block. You should be able to slide the block in and out, but still feel some friction. We'll need to repeat this step for the other side. With the Z-axis set, we'll want to set our Y-axis. To do this, we'll actually grab the actuator, don't touch the screw, and gently push it back until we can fit the same setup block between the carriage and the end block of our Y-axis. So we're going to use this block. We'll actually pull the carriage back and index it against these blocks. We'll repeat this for both sides. With both axes set, we'll reapply power, and then we'll home the machine to re-zero it. Our next step will be to level out the build plate. Now for this, we'll need a couple of tools. We'll need a dial indicator. This one has 2 inches of travel, and it has a bracket to clamp onto the extruder. We will also need a set of metric hex wrenches. The next step will be to mount the dial onto the extruder. For this dial, we need to raise the Z-axis up 30 millimeters and push the Y back 100 millimeters. So for this bracket, we just slip it over the extruder motor. We'll use a 4 millimeter hex wrench to clamp it down. This procedure will change depending on what dial, bracket, and extruder you're using. Now that we've got our dial mounted, we're going to actually move the dial to the center of the bed to set our zero position. So we're just going to move it out in X and Y until it lines up with the center of the bed. There's a small mark in the center of the build area where the bed level pin is located. Just move the dial out so they're lined up. And then we'll turn the dial to set 0 at this position. Now that we've got our 0 position set, we'll move the dial around to all 9 adjustment points, including the center, and adjust them all to our 0 position. We may have to repeat this step 2 or 3 times, as every time we adjust a screw, it will affect the level of the entire bed. So to adjust each set of leveling screws, first we have to loosen the button screw. This one's the lockdown screw. That's what holds our position in place. We're just going to take our 3 millimeter wrench and we're going to turn this counterclockwise to loosen it. Now that we've loosened that screw, we can use the second screw, the jack screw, to actually set the height. Because we're a little bit high, we're going to turn the screw counterclockwise and lower the bed. You can see the dials moving into position. Once we hit 0, now we can go back to the lockdown screw. We can turn this clockwise to tighten it back up, and we've set our point. Be careful not to over-torque this screw. The adjustment for the center pin is slightly different. We adjust that from the back of the machine. We've got a set screw and a knob. So to adjust the center pin, we're going to back off the set screw to allow adjustment. Once that's loose, we're going to turn the knob. We're going to turn the knob counterclockwise to raise the center pin. And we're going to turn the knob clockwise to lower the center pin. Once we're done setting the center pin, we're going to retighten the set screw to lock it in place. Now that we've set our bed level, we're going to go ahead and set our extruder level as well. For this, we just need a couple of tools. We need the same metric hex wrench set. We also need some shims. So I've got a 6 thou, an 8 thou, and a 10 thou shim, which comes out to 0.15, 0.2, and 0.25 millimeters. To prepare our extruders for leveling, we're going to set temperatures. We'll set the bed temp to 70 degrees. And then we'll set both extruders to 200 degrees. After we set our extruders, we're going to move the nozzles out to the center pin of the bed, right where we set our dial during the bed leveling portion. Just as a side note, for the WorkSeries controller, we can only set one active temp at a time. So for the left extruder, set the active temp to 200. For the right extruder, set the standby temp to 200, so they'll both heat at the same time. So we're going to set the extruders now with our brass shims. We're actually going to set the left and the right at slightly different heights. The left, we're going to set it at 6 thousandths or 0.15 millimeters. The right, we're going to set it at 8 thou or 0.2 millimeters. And the reason we have that offset is we're treating the left as the primary extruder in the setup. So we don't want any chance of interference if we're just running the left. If we're running a dual extruder print, both nozzles will be heated, so there's no chance of interference. So we're going to set our two extruders now. We're going to set the left one first, then the right. These ones are volcanoes, so they have a certain bracket. Depending on what extruder you have, if you have the HFA, there may be a slightly different bracket, but the adjusting process will be very similar. We're going to take our hex wrench. In this case, I need a 3 and a 4 millimeter. We're actually going to back out these two screws, loosen up the extruder so we can set the level. For our left extruder, our primary, we're going to take our 6 thousandths or 0.15 millimeter shim. We'll slip that right underneath the nozzle, and then we'll use the jack screw to adjust it until it's a nice fit. The shim should be able to slide, but there should be some friction, just like when we're setting our axes. When we've got a nice fit, we're going to retighten these screws down to hold the extruder in place. And then we're going to use the next shim size up to double check our nozzle height. Because we've set our left extruder with a 6 thousandth shim, we'll use our 8 thousandth shim, a 0.2 millimeter shim, to double check. The 8 thousandth shim should not be able to fit underneath the nozzle. So right now, it doesn't quite squeeze under there, so we're at a good height. So now I'm going to take the same shim, the 8 thou shim, and I'm going to set the right extruder with this shim. Repeat the same process. We'll loosen our two screws. Then we'll use our jack screw to set the height. And then we'll retighten our screws. Because we've used the 8 thousandth shim to set this, we'll use the next size up to 10 thousandths with a 0.25 shim to double check the right side. So now that we've got our extruder set, we're going to run a series of calibration prints to validate our setup. So the first one we're going to run is called the chip. So we'll just go to our control screen, open up our SD card and choose chip left, the first chip print. We'll just start that one up. The chip print is to validate our extruder height. So we're going to print it and then measure as needed. So once we've completed our chip print, we've got it looking visually good, we'll use our caliper to confirm our measurement. Let's take our caliper, we'll measure across the flat. This comes out to 0.36 millimeters, which is exactly right. You can always check the screen during the print to see what the proper Z height should be. Now that we've completed our first calibration print, we'll repeat the process for the rest of the prints in the startup procedure. Now that we've completed most of our calibration set, we'll move on and do the dual calibration print to set our tool offsets. So we're going to start the calibration print right now. Control menu, SD card, choose dual extruder calibration, and press print. The dual extruder calibration is a bit trickier. We're going to print it, and then we'll have to take careful measurements to input to our calculator, which will give us our new tool offsets. An easy way to check the current tool offset with machine honed is just press tool 2, and the current offset will be displayed as a position. With the calibration print complete, we'll use a set of calipers to measure it. Well, we're measuring in the X now. This is measuring 29.88 in X. Then if we measure it in Y, it comes out to 29.98. So now that we've measured our values for our dual calibration print, we'll enter them into our calculator. First, we enter the current X and Y offset for our machine, and then we enter the measured values. So we'll enter 29.88 for X and 29.98 for Y.
When we enter those values, it's going to spit out the new machine offsets down below. So we can take these two offsets and we can insert them into the controller. So you can either enter this G code, or to save them, we'll go and edit the config file and add the G10 line.